The topic is finding the differential of a function of two variables. So let's do the first example. Determine the true change in the function f of xy equal x squared plus xy from the point 1, 2 to 1.1, 2.2. Now, they're asking us to find delta f, right? Or delta z, it's the same thing. Delta f, the change into the change in the function from this point to this point. Now, how do we do that? By definition, if you look at the definition, it's always going to be f. Think of this, the x, this is my x, and this is my y. The x increases by 0.1, right? And the y value increases by 0.2. This is what we mean. In this case, x happens to be 1. Well, this whole thing is 1.1. This whole thing is 2.2. And the x happens to be 1 and the y happens to be 2. But the delta x, we're going to calculate it later anyway. So this is going to be f of 1.1, 2.2 minus f of 1, 2. So delta f or delta z is equal, how do we calculate f of 1.1, 2.2? Just plug the x here and the y there. So that would be 1.1 squared plus 1.1 times 2.2, right? This is just this part minus, and then f of 1, 2, again, plug it into the function, 1 squared plus 1 times 2. So use your calculator. If you do that, you're supposed to get 0.63. So this is the change into the function from 0.12 to 1.1, 2.2. Now compute df. Now df, by definition, we need to find fx, partial derivative with respect to x. So fx of any xy will be equal what? Partial with respect to x of x squared plus xy. This is going to be equal to x plus partial with respect to x of xy. Y is a constant, so that would be y. Now therefore, partial with respect to x at the point 1, 2, we go by the first point, so 1, 2 will be equal 2 times 1 plus 2, which is equal to 4, right? Now I need to find partial derivative with respect to y. So again, partial with respect to y of any xy will be equal partial with respect to y of x squared plus xy. Now partial with respect to y of x squared is 0 because x squared is a constant. And then since x is a constant, this will be just x. Now this means partial y, at 1, 2 will be equal, just plug a 1 into x, it will be equal 1. X is what? Yep. X is 1. Partial with respect to y, yep. Alright, now what's next? Now this means that df at the point 1, 2 will be equal, what is fx? Fx is right here, so it's going to be 4 dx plus 1 dy, right? But remember now the dx and the dy's are given. Dx is always delta x, dx is equal delta x, dy is equal delta y. So what is, how do I calculate? Let me see. So dx, let me write it here. We know that dx is the same thing as delta x, which is x2 minus x1, right? So it's 1.1 minus 1, which is 0.1. Now what would it be? dy. dy is the same thing as delta y. So it will be y2, 2.2 minus y12. So 2.2 minus 2, which is 0.2. So now we can even calculate df from the point 1, 2 to the closest point 1.12.2. So df will just be equal 4 times my dx now is given 0.1 plus dy is 0.2. And this is going to be equal 0.4 plus 0.2, which is 0.6. Right, so the df is 0.6. I mean, yes, and the delta f is 0.63. So what does those two represent? This represents the change in f from those 2 points, the true change in f. The df is kind of like the height, the difference of the height. This is like the height from between those 2 points to the tangent line. So there's a big difference. But of course, the df will always be since, let me write it here. To compare them, first of all, to compare them, 0.1 delta f we said is 0.63, df is 0.60. So they're kind of like almost equal. But the reason why they're equal, because these 2 points that we pick, the point 1, 2 is near the point 1.1, 2.2. So if we pick another point that's really far from 1, 2, this is not going to hold. The delta f, what am I saying here? So far we know that the delta f is almost equal to df. That's the comparison. So if we pick a point that's not near 1, 2, this is not going to work out. They are not going to be almost equal. Alright, that's it for this example.